When the saga of interstellar visitors reached a new and unexpected peak, astronomers were confronted with something unlike anything they had ever seen. This wasn't just a lone interstellar traveler streaking through the void, it was accompanied. What appeared at first to be a single, fast-moving comet soon revealed a fleet of massive, unidentified objects moving alongside it. The cosmic visitor, designated 3I, Atlas, has reignited one of the most provocative questions in modern astronomy. What exactly is drifting through our solar system? And could some of it be intelligently made? To put things into perspective, 3I, ATLAS, officially the third confirmed interstellar object after Oumuamua in 2017 and 2I, Borisov in 2019, entered our solar system on a hyperbolic trajectory. It was moving far too fast to be bound by the sun's gravity, meaning it came from another star system entirely. But soon after its discovery, telescope networks such as the Asteroid Terrestrial Impact Last Alert System, ATLAS, in Chile and other observatories around the world began detecting anomalies, signals and reflections that didn't fit the profile of a normal comet or asteroid. Instead of a single nucleus, astronomers found evidence of multiple large objects traveling with it, some appearing to orbit or drift close to the main body. To many, it sounded like science fiction, a mothership releasing probes. But the data was there, massive unknown companions, moving in unison across the dark canvas of space. These mysterious companions defy easy classification. They might be fragments, colossal chunks of rock and ice torn from 3I, ATLAS during its passage through interstellar space. Or they could be independent bodies, gravitationally linked to the main object like a family of moons orbiting a distant, alien comet. But the third possibility, the one scientists speak about only in whispers, is that these are non-natural structures, artificial constructs traveling together as a coordinated system. Estimates suggest that the primary nucleus of 3I, ATLAS could be up to 6 kilometers wide, larger than most known comets that pass near our Sun. Its hyperbolic orbit confirms its interstellar origin, a visitor not born of our solar system. Yet its behavior is strangely complex. Rather than disintegrating as it approached the Sun, 3I, ATLAS began exhibiting new emissions, strange light curves, and dynamic fragmentation patterns inconsistent with any known cometary process. Some astronomers propose that the so-called massive unknown objects could be remnants of a binary or even multi-object system ejected from a distant planetary neighborhood. In such a case, 3I, ATLAS may once have been part of a moon system orbiting a larger planet or a binary minor planet pair, a celestial family cast adrift after a gravitational upheaval. If true, this discovery would mark the first time humanity has observed an interstellar system composed of multiple bound bodies, not just a solitary wanderer. The implications of that are staggering. It suggests that star systems throughout the galaxy regularly eject not single objects, but clusters, fragments of worlds, moons, and planetary debris traveling together for millions of years. It means our galaxy may be filled with hidden convoys of alien material silently crossing the stars. For now, scientists are racing to gather as much data as possible. The Hubble Space Telescope and the James Webb Space Telescope have both been directed toward 3I, Atlas, capturing its faint glow and analyzing its spectral fingerprints. Webb's infrared instruments, in particular, are searching for telltale signs of volatiles, frozen gases and organic compounds that could reveal the body's origin and composition. But the introduction of these additional, unknown masses complicates the analysis. Every observation must now separate the main object's signal from its companions, each potentially emitting its own light and gas signatures. If these companions are indeed gravitationally bound, they would represent an incredible level of structural stability, surviving ejection from a star system, enduring interstellar radiation and collisions, and remaining together for what could be millions of years of travel. That kind of endurance challenges our understanding of how fragile icy bodies behave beyond their home stars. As 3I, ATLAS continues its journey through the inner solar system, approaching about 1.4 astronomical units from the Sun, just inside Mars' orbit, scientists expect increased activity. Sunlight will warm the object's surface, causing gas jets and dust plumes to erupt. If the unknown companions are close enough, their motion may alter, revealing whether they are truly bound to the main body or simply traveling alongside it by coincidence. In the coming weeks, observatories across Earth and Mars' orbit will watch closely for separation events, dust trails, or sudden brightening, all potential clues to the nature of these mysterious travelers. What makes this event so profound is not only the discovery itself, but what it represents. For decades, we have modeled interstellar visitors as isolated, inert chunks of rock and ice, lone emissaries from distant stars. But 3I, ATLAS challenges that idea. It hints at a galaxy alive with dynamic systems, complex, multi-bodied wanderers carrying the history of alien worlds. From an astrobiological standpoint, this opens thrilling possibilities. If such objects carry organic molecules, carbon compounds, or amino acid precursors, then interstellar clusters like this could be the true messengers of panspermia, natural couriers spreading the building blocks of life from one planetary system to another. They could be the seeds of life scattered across the Milky Way. Even more intriguing is the idea that the unknown companions could be remnants of advanced construction, relics of technology from civilizations long extinct. While there is currently no direct evidence supporting this, the unusual structure and composition of 3I, ATLAS leave room for cautious speculation. In a universe of hundreds of billions of stars, can we really rule out the possibility of ancient machines drifting between them? From a practical standpoint, 3I, ATLAS also serves as a wake-up call for planetary defense and observation. Our solar system is far from isolated. Interstellar objects, some possibly much larger than we realize, are passing through more often than once thought. The arrival of this multi-body system underscores the need for next-generation sky surveys capable of detecting not just solitary comets, but entire clusters, fleets, or complex interstellar formations. Imagine the next generation of missions, spacecraft capable of intercepting such visitors, mapping their surfaces, and collecting material samples before they vanish back into the darkness. Future explorers may one day touch the dust of another star, tracing its chemistry to places we can only imagine. But for now, as 3I, ATLAS glides past our Sun and back into interstellar space, we are left with a profound reminder. Our solar system is not an island. It is a crossroad in a vast galactic network, one that occasionally receives silent visitors from the far reaches of time and space. And every one of them carries a story, a piece of a cosmic puzzle billions of years in the making. So, what are these massive unknown objects? Fragments of a shattered world? Companions from a lost planetary system? Or something even more extraordinary? One thing is certain. 3I, ATLAS has changed how we see our place in the cosmos. It has reminded us that the universe is not a still ocean, but a living, drifting sea of wonders, where worlds are born, destroyed, and reborn again among the stars. If you enjoyed this exploration, don't forget to like, comment, and subscribe to Wave's Discovery for more mind-expanding insights into our mysterious universe. Until next time, keep looking up, because the next visitor might already be on its way.